So hello, today we're going to do practice problems for chapter 22, our third chapter. Um, I'm going to be honest, the exam problem on this chapter is almost definitely probably going to be a Kochov loop, but I'm going to do some problems involving not Kochov loops also, just mixing up a few different things because, well, the other stuff sometimes shows up on the final. In general, this chapter does cover a lot of other things, mostly involving resistors. Starting with just resistors in general to resistors in parallel and series, Kochov loops, RC circuits, and so on. I kind of have spread across the screen a whole bunch of things we could need. The electrician circle, which gives us most of the equations we could need, resistance of a resistor, and down here in this kernel, just resistors in parallel and series, and capacitors too in the same document. But I'll pull from the different ones as needed. And this first question says, the potential difference of 12 volts, which means a voltage of 12 volts, is found to produce a current of 0.4 amps. So current 0.4 amps in a 3.2 meter length of wire. Of radius 0.4 centimeters. So my R, it's 0.4 centimeters, that means 0.004 meters. Okay, so that's a bunch of the first thing is what's the resistance? If I want to find the resistance, I'll go right to my resistors circle. Sorry, my electrician circle. I misspoke. How to read this is if I want to solve resistance, I'll go to my resistance section. And I have three equations for resistance. Now, I don't know P, so this guy's out and this guy's out. I have to use this last equation and say resistance equals V over I. And so, okay, well, autofocus is off. There we go. And so I can look at it and say, okay, if I want to find the resistance, I'm just going to say it's 12 volts over 0.4 amps. 12 volts over 0.4 amps is 30 ohms. Quick thing on this, nice and straightforward. On the homework, you will be needing to sometimes put ohms. If you know how to put a capital omega, that will work. If not, you can literally just type the word ohms. Okay, part B. What's the resistivity of the wire? Well, resistivity, which uses the symbol rho, is going to follow by this equation right here. That resistance is resistivity times length over area. Well, normally I do a lowercase l. Oh, I did that too. Okay. Yep. So if I want the resistivity, I'll multiply both sides by the area and then divide both sides by the length. And I can say, okay, it's 30 ohms times the area, but I didn't actually find the area. I said the radius. But, well, I gave a radius. If I give a radius, the thing is obvious, it must be round. So if I want to find the area of the circle, that's going to be pi r squared, or pi times 0.004 meters squared, which is 5.0265 times 10 to negative fifth meters squared. So I'll put that for my area. Over the length, which was 3.2 meters. And I can get my value. Part C, what is the power dissipated by the wire? So now I want to find power. So I'm going to go to this kernel. And I have three different equations to use. And the thing is, I can use any of those equations. I know all three terms. I know V, I know I know all. So it doesn't matter which one I use. I'm just going to use IV because that way I don't have to worry about squaring things. And the more often I square things, the more likely I am to make a stupid mistake. and get a value. This is a very straightforward problem. This is definitely too simple for something I'd put on an exam. I wouldn't put anything quite this simple on the exam. But it's just to get you the idea across of dealing with these resistances and powers and currents and voltages. Okay?
All right.
Let's do a more difficult problem. And I'm going to look at this guy. This problem, a little more complicated, says look at these resistors, and I'm trying to just see if I can, too much. Okay. Says consider this resistor shown below. And it starts with find the equivalent resistance. Now I could try to do equivalent resistance. I'm going to have to go and add them up in pieces. And what I can do is say, okay, just looking at this, 1 and 2 are in parallel with each other. 4 and 5 are in parallel with each other. And you know what? I'm not going to worry about the text. The word, oh, you know, I just make this a little wider. Then I don't have to worry about it. There we go. 1 and 2 are in parallel with each other. 4 and 5 are in parallel with each other. And what I'm going to do is I'm going to say that that diagram, matching my colors, is the same as this. Well, what I'm saying is this is still resistor 3, but this would be a resistor 1, 2. And this would be a resistor 4, 5. Well, resistor 1, 2 is just the equivalent resistor of resistor 1 and resistor 2. Resistor 4, 5 is the equivalent resistor between resistor 4 and resistor 5. Now, those resistors are in parallel. And in parallel, resistors follow the inverse rule, meaning 1 over resistor 1, 2 equals 1 over resistor 1 plus 1 over resistor 2. And using the numbers, was it 12 and 6? 1 over 12 ohms plus 1 over 6 ohms, which is the same as 1 over 12 plus 2 over 12. We get that 1 over resistor 1, 2, 1, 2, I can write, is 3 over 12 ohms, which 3 over 12 is a fourth. But that's not resistor 1, 2, that's the inverse of it. So all 1, 2 is 4 ohms. Now as for resistor 4, 5, which I'm going to do right here, 1 over all 4, 5 is 1 over all 4 plus 1 over all 5, which means it's 1 over 4 plus 1 over 8. And I'll use the same logic. 2 over 8 plus 1 over 8. Which means 1 over all 4, 5 is 3 over 8 ohms. And then I can invert that. That means all 4, 5 is 8 over 3 ohms, which is 2.6 repeating. See, once I put those together, and let's just circle these in my almost useless pen, just so I don't lose track of them. Oh, I put it over there for the other one. Or I can just put it up here. That makes sense. 2.667. Once I have those, now I just have 3 resistors in series. And if I just have these 3 resistors in series, I can say, hey, look, if they're in series, I can treat them as one resistor, where the equivalent resistance of this would just be the sums. All 1, 2 plus all 3 plus all 4, 5. Which is going to be 4 ohms plus 5 ohms plus 2.667 ohms. 5, 9, 10, 11, which is 11.7 ohms. Well, I dropped I went to only 3 sig figs, whereas keeping more just to keep track. Well, I guess I'm adding, so it shouldn't be, still should be 3 sig figs. And there you go. That's the equivalent resistance. But that's only part A. Part B says 35 volts is applied to this. What's the current on each resistor? So I'm going to need a bit more space to do this. So I'm going to really quickly, and I'm not going to worry about color coding at this time, I'm going to draw this again 3 times. And I'll put this visible. 01, 02, 03, 04, 05, 012, 03, 045. Only the neatest work for me. You can see why I normally type everything I give you. So I'll be pulling numbers from the other page as I continue. So we know R12 is 4 ohms. R45 is 2.667 ohms. And down here, R equivalent equals 11.7 ohms. Okay, collecting that information again. If I want to find the current through each resistor, what I can do is, I could Kochov loop this, but there's no need. Because I can say if this is hooked up to one battery, and it says 35 volts over this, I can say if this was hooked up to one battery with 35 volts, that means the voltage of the equivalent is 35 volts. Now, we know V equals IL, or if I go to my circle, I can see that I is V over all. I can find I equivalent. That I equivalent is V equivalent over all equivalent, or 35 volts over 11.7 ohms. 35 volts, 11.7, which is 3 amps. So that would be the current through this guy. But this doesn't really exist. This is just saying, hey, that would be the same as this setup. So I can use that for this guy. But here's the thing, they're in series. In series, all resistors have the same current. I12 equals I3 equals I45. And that current is the same as the equivalent. And there we go. I know that the current through all 3 is 3 amps. But I got to get the other guys. See, the other guys, I can't just jump straight to their current because they're made up of pieces in parallel. And in parallel, the voltages are the same. The currents are not. So I have to find the voltages of them. But since V equals IL, that means V1 equals I1 R1. V2 equals I2 R2. And, I'm just going to keep, so I1, oh, sorry, I lied. I should do I1, V12 and V45. Let me just start that a little bit over again since I made a slight mistake, and I'm just going to do it downhill. I don't have R1 and R2 yet. I just have this guy combined. So yeah, I'm going to say V12 equals I12 R12, which is 3 amps times 4 ohms, so it's 12 volts. V45 is I45 times R45, which is 3 amps times 2.667 ohms, which was what, 8/3, so 8 volts. Okay, that's the voltage on, let's just start with 1, 2. If the voltage on 1, 2 is 12 volts, I can use the same logic that if this is made up of ones in parallel, they have the same voltage. That V1 equals V2 equals V12 equals 12 volts. V equals IL, so that means I1, I V over all, is V1 over R1. or 12 volts over 12 ohms. I2 is V2 over R2, or 12 volts over 6 ohms. Now, of note, 2 plus 1 is 3, which is good, because that was the equivalent current when they were added together, so it's good to make sure. Likewise, I can do the same thing for my 405. I4 equals V4 over R4, which was 8 volts over 4 ohms. I5 equals V5 over R5, which is 8 volts, and it must be 8 ohms. 8 ohms. And that gives it to me. I get every one. It's time consuming and annoying, but you just kind of plug your way through, and just like the capacitors, work your way to equivalent and then work your way back, and you should get it. Any questions from the literally one person in the room? That's
So this is essentially exactly the same as what we were doing with capacitors last chapter.
It's essentially, it is the same. The only difference is current was, let me grab my pen.
Yeah, like the individual properties between
Yeah,
parallel.
current was replaced with charge, or other way, charge was replaced by current, right? But also how you add a capacitor and how you add a resistor are opposite of each other. But the process is the same.
Okay.
Like the fine details changed, but the process didn't.
Alrighty.
This next one is the more difficult one. And this next one is something most similar to what's probably going to be on the exam. And this one's actually an easy one because I gave the directions of the current, which is unlike me. I don't know why I gave those. On the homework and on the lab, you will not be given those because the next lab is dealing with current. Oh, not the lab I released yesterday. The lab I released yesterday is just Ohm's law, but the lab after that is dealing with Kochov loops. And what I say is, in the circuit shown, determine the current in each resistor. You will need to use Kochov's laws. So, Kochov's laws, or Kochov means I'm gonna want to go, and first I got to figure out what currents I'm measuring. And you know what? I'm not gonna bother drawing the picture. I can edit this picture over here instead. That'll be easier. That's what my pen on screen is for. And so here's what I got. I have 3 currents already labeled. Normally when you're doing this, you start by guessing the direction of each current. But as I said, they did that here, so I don't need to do it. And the current should hold the same throughout each piece, which means I1 is really all of this. I2 is really all of this. And I3 is just this middle piece. The current should be the same except when you hit a junction. And for Kochov's rules, I'm going to have 2 rules I need to deal with. The first is the junction rule. The junction rule says on any junction, the current in equals the current out. So I'm going to look at the junction right here. And if I look at this, what I can see is that I1 goes into that junction, and I2 and 3 go out. So I1 equals I2 plus I3. And there's my first rule. After that, it becomes time for loops. Now I have 3 unknowns, I1, 2, and 3. So I'm going to need 3 equations to solve it. However, I have 3 different, I only have 1 equation, so I only need 2 more. But I have 3 options for loops. Excluding direction, I could do the whole thing, just the bottom, or just the top. Now, which 3 I pick doesn't matter. It'll change mathematically the process of solving it, but I could do any of them I want. I started with this loop, going uphill, overhill, downhill to heel, heading in that direction. So, what Kochov's loop says, or Kochov's law says, is on any closed loop, the sum of the potentials is 0. And so I'm going to see what I pass over. See, if I follow this loop, I first go over the battery. And I'm going from the battery from negative to positive. When you pass over a battery from negative to positive, you add the potential. I then pass R2. I pass R2 in the same direction of current because I1 is going to the right and we're going to the right. So that's going to be negative, as shown in that. Now that is R2. I1 is passing through it though. So I'm going to say that is I1 R2 because that's the potential through a resistor. I then go through resistor full, and I'm still heading in the same direction of the current, minus I1 all full. I then make the turn, and I start passing through the current 3 section, because once I do that left-hand turn at the bottom, yeah, I'm now in current 3, but I pass over resistor 3, and I'm still moving in the same direction of the current, minus I3 all 3. And that's that loop. Okay, I need another loop to solve this. Okay. As I said, normally I just kind of pick one and go for it, but I'm trying to match the solution. So the other loop I'm going to do is I'm going to start at this kernel and do the big one. Now with this, everything's going in the right direction again, which is kind of nice. I should replace this with a more complicated one. So on my way up, I go battery 2, going from negative to positive, so that's good. Then I go over battery 1, negative to positive, so that's good. Then I go over R2 with the current. Then R4 with the current. Then I'm in the second current area, but I go over R1 with the current. And then R5 with the current. And there's my second equation. So there we go. I have 3 equations. Once you have your 3 equations, it's just math. As I said, there'll probably be an exam problem on this. I had, I think, 20 out of 25 points for getting to this point, and only 5 points for doing the math, I think is what I did. So I'm going to start solving this. The way I like to do these is, okay, I'm solving for I1, I2, I3. I1 is in all 3 equations. So, wait a second, there's a slight mistake here. There is a mistake here. That was I1. I1, R2, I1, R4. Yep. I1 is in all 3 equations. So what I'm going to do is I'm going to take my 2 loop rules, and I'm going to solve for the bits that isn't I1. So I'm going to solve this guy for I3, and I'm trying to color code it. The black and the blue looks really similar. Maybe I'll switch this guy to green when I go back because the black and the blue look too similar to me. But I'm going to solve this guy for I3. I'm just going to add I3, R3 to both sides. And then divide both sides by R3. Am I doing the same process as I did before? Okay. So I'm going to be honest about something. I always tell you to never plug numbers in right away. I sometimes do with the Kochov loops just to hope to make it less complicated. I mean, this thing's pretty complicated. If I was to plug in numbers right away, this would be 24 volts minus I1 times, what's all 2? 2 ohms minus I1 times 4 ohms over all 3 ohms. That's 24 volts minus 6 I1, which is 24 over 3, 8 amps minus 2 I1. I did that just to simplify it. You don't need to do this. You could leave it all in terms of terms, and no, I often will when doing them, but this is going to get ugly. This is a real mess. This isn't such a mess. I'm just going to do it. Meanwhile, let's go back to my blue equation. I'm going to solve this one for I2. So I'm going to take both my I2 parts and add them to both sides. I2 all 1 plus I2 all 5 equals V2 plus V1 minus I1 all 2 minus I1 all 4.
So just a quick question.
Yes.
When you simplified that last bit, you canceled out the 6 and the 3 to get a 2.
Yep.
Is there still supposed to be an ohms there, or do the
No, because the ohms cancel.
units cancel?
The units
Okay.
cancel. And think about it, because this is a current, so it should. This is in amps, and this I is in amps once I plug something in, so it works.
Okay, yeah.
Yep.
All
Okay,
right.
so I'll factor this side together, which I'm not going to bother writing this whole other bit again. I'm just going to say this right side can become I2 all 1 plus all 5. Just kind of jagging it onto the side, but I'm just factoring that I. And then I'll divide by that. I2 equals V2 plus V1 minus I1 all 2 minus I1 all 4 all over all 1 plus all 5. Now, once again, I could work with this, but I'm going to plug in some numbers and hope it simplifies. So I need 12 volts plus 24 volts minus 2 ohms I1 minus 4 ohms I1 over 1 ohm plus 5 ohms, which is 12 plus 24 is 36. Negative 2, negative 4, negative 6. And 1 plus 5 is 6. 36 divided by 6 is 6. And there's another equation. So here's what I got. I1 equals I2 plus I3. However, I3 is this, and I2 is that. And so I'm going to take this top equation, and I'm going to say I1 equals I2 plus I3. And I can solve, oh, I'm off the bottom. And I can solve that. That says I1 equals 8 plus 6, 14. I just blanked on that math for a second because that's the way my head's at. 2 and 1. I'll add this 3i to both sides. Running out of space. And then that means I1 equals 14 amps over 4, which 14 amps over 4 is a half a 7. So it should be 3.5. And there you go. That's one of them. The direction was correct because I got a positive number, but that's only one of them. Now that I have that 1, I'll plug it into everywhere else. 8 amps times -2, oops. 8 amps minus 2 times 3.5 amps, which is 8 amps minus 7 amps, or 1 amp. I can plug into this one. 6 amps minus 3.5 amps. And I can get all 3 values. I kind of cramped a little bit because I was trying to fit it in half a page because that's what my doc cam shows. I wish I could show a full page. But that's the process. As I said, the math is the annoying part. But that's just the math. Once you have the loops, that's be most of the points. The homework will have some practice on these. The ones on the homework, I don't start with labeling the eyes direction. Just label them however you want. And if you get a negative answer, know your label is in the backwards direction.
So going with the current is negative, right?
Going, be careful. When you get a final answer, if you get a positive answer, that means the current is the right direction. So what I think what you're asking is if you're going over a resistor, going with the current is negative.
Okay.
So this is the annoying thing, is that resistors and batteries have different rules for this. So divide that off. When you're going with this figure assumes you're going from A to B. So when you go with the current, it's a negative IR. When you go against the current, it's a positive IR. Batteries don't give a shit which way the current is. They drive the current. They decide such things. Batteries, it's positive when going from negative to minus, and negative when going from positive to minus. I have last semester's exam or last year's exam is already posted on Banco Hall, so you can see like what was on the exam. But I'm going to talk about that. There's too many things on my screen. Later on, but I'm just going to pull that one up for a second just to give you an example of what I mean by that. Fall 2019, Physics 2, Exam 1. There was a mistake on the exam, which is why there's a fixed version. So like this one, when I was doing when you do the loops, the loops at some point is going to have you go the wrong way on a battery, no matter what, because they were all parallel pointing like this. And so like going this way, I'd say plus V1, and going this way, I would say minus V2, and so on. I will be solving this problem in class before the exam.
So is it always going to be an I1, an I2, and an I3, or are there going to be instances where there's like even an I4? Or maybe
I could do one with an I full. This 5th problem has an I full.
Is it just depending on how many rungs of the parallel
Yeah,
circuit there is?
exactly. Yep. The problem with going to having an I full is instead of you have to solve 3 equations for 3 unknowns, you have to solve 4 equations for 4 unknowns. I won't put one that goes up to 4 on the exam just because literally adding a 4th one just makes it more time consuming. It doesn't make it, I mean, it's total because it's more time consuming, but it doesn't like add like me testing new bits of information. It's just like, can you do the math for a longer period of time, which isn't my goal in an exam. Usually the last problem in these packets is something more difficult than something I would give you, and this is an example of that. I won't give you one with 4 on the exam. It's just,
Okay.
it's a pain in the ass. And like this one I just put up. Wait. This is the type solutions. They're on Banco Hall. Like this is my solution to that one with 4. Like goes on to a second page because it's just like all of these solving things.
So yeah, thank you for not planning on putting one on the exam.
Yep, I try to be nice about that. That being said, I am going to do one last problem today. Ooh, and I didn't put up the equations for this one. They are not visible right now, but I would just cover the equations as we do it. So the last thing that's going to be in this chapter is the RC circuit. This probably won't be an exam since, as I said, I plan on doing a Kochov loop. The Kochov loop is the big thing for this chapter. Like, that's the important thing. And most of the time, RC circuits in DC aren't very important. We're going to talk about RC circuits a lot more when we do AC, and I'll cover them in more detail then. But what it says is, we got this RC circuit. R is one. Wait, there's a typo there. That says 1 megavolt. That makes no sense. And on the other thing, it says mega ohm. I'm thinking this is just a typo. So that should be 1 mega ohm. I'll fix that in a second. Mega ohm. Good enough. 5 is C is 5 microfarads, and the battery is 3 volts. Step 1, find the time constant. Time constant is RC. So it's just 1 times 10 to the 6 ohms times 5 times 10 to the negative 6 farads, or 5 seconds. 2.
Is that always the same?
Yeah, time constant for a RC circuit is RC.
Okay.
For any RC circuit. And that'll be true even when we get into AC later on. Time constant will still be RC. That being said, it can throw off if you start adding other things. Eventually, we'll be adding inductors also. Then it gets a little more complicated. All right. B, maximum charge. The maximum charge, Q equals CV, which in this case, Q equals C times epsilon. So it'll just be 5 times 10 to the negative 6 farads times 30. And C is an actual real problem, which says, find the charge on the capacitor 10 seconds after the switch is closed. This is a capacitor that is charging. We know it's charging because it's showing with a battery. You don't bother the battery when you're charging. And it's also starting open. If it's open, it wouldn't have a charge on it. So we're showing this going, closing it, and we're going to charge it. When you charge a capacitor, the charge on the capacitor goes as a function of charge equals initial charge, times 1 minus E negative T over RC, or negative T over tau. And therefore the charge is going to be the maximum possible charge times 1 minus E to the negative 10 seconds, 5 over 5 seconds. Which is 1.5 times 10 to the negative 4 coulombs times 1 minus E to the negative 1/2. E to the negative 1/2. I'm just not bothering by that number again. E to the negative 1/2 is 0.606531. And when I can multiply that through negative 5 coulombs, you can get the charge.
Wait, would it be E to the negative 1/2 or E to the negative 2?
E to the negative 2. Wait, 5. I wrote this backwards, didn't I? I wrote them backwards here because it's T over tau. So
Okay.
This is 10 seconds. That was 5. Sorry. I just wrote them backwards. So it is 1/2. I just am an idiot. You'd be amazed how often the answer is that I'm being an idiot.
I'm just surprised I caught that.
I'm happy you did, since it could be immortalized in video. Any questions?
Nope, not yet.
All right, well, I'm going to stop there, actually. So that's the practice for this one. Yeah. And then homework for this is due Wednesday. And then we'll start next chapter on Monday. I've started writing the exam. I haven't gotten very far because I like to make my exam questions interesting, and it's really fucking hard to do with this stuff. But I'm getting there. Otherwise, that's it.